Welcome to Biology Minds. Today we're going to talk about fingerprints. So when we talk about forensic science, we are always talking about the different evidence and how we're going to process that evidence. But a major thing that we have to always consider are fingerprints. So something that really changed the game when it comes to forensic science is fingerprints. So before there were fingerprints, not only could we not use them as evidence, so before we knew that fingerprints were useful, we couldn't use them as evidence, but we also couldn't use them to identify individuals. So if you are ever become an employee of the state or a federal employee, or you're ever an inmate in a prison, you're going to have your fingerprints taken. Right? You commit any major crime, your fingerprints are taken. So, that is a way of identifying you separate from any description of you. But before there were fingerprints, they had to use other means of identifying or IDing people. So before fingerprints, back in 1883, and before we needed to use the Bertillon system, and the Bertillon system was really based on body measurements and a description of a person as well as their photo. So you needed this all-encompassing way of identifying individuals. So we use their body measurements, which is called anthropometry, and we use the detailed description, which they called a portrait parlay, and then they also had a full-length photo as well as a profile photo like you see in mugshots. So we needed all these things, and we needed to make sure that everything lined up, and that's how we really ID'd people. So this is called the Bertillon system. This is before fingerprints were used. And Francis Galton, around this time in the late 1800s, he started conducting research that indicated that fingerprints were individualized, meaning that they were very specific to an individual person and could potentially be the best mode of identification, far better than using the Bertillon system. So he was able to come up with these categories of prints. He looked at all different people's prints, and he noticed that every print seemed to fall under a specific category that he came up with, and he said that everyone is either a loop, an arch, or it is a whorl. So all of them, there's only three different patterns or basic patterns that we look at. So um, he said that, hey, we can look at these fingerprints and they're going to be individualized to a person, and we can actually put a name to each print, whether a person has loops, arches, or whorls, or a combination of each one. So before we use the current classification system that we use, which is the Henry system, there was a Vujacic system. So this guy, Dr. Juan Vujacic, he created the first usable classification system, and he took what Galton said, and he was able to come up with a systematic way of identifying fingerprints. And it's still used in some Spanish-speaking countries, but now in all English-speaking countries and a lot of other countries, we use this Henry classification system. And this came about in 1897. So we file fingerprints based on this Henry classification system. In 1901, the U.S. started using fingerprints and finding their significance in IDing people. So they started to see that, this is before they started to see how helpful they were in investigations, but they could see that they were very important in creating a database of people to identify people, rather than in our prison system using that Bertillon system. We could now use fingerprint system in order to identify different inmates. So in 1903, William West and Will West, they were two different people, and they revealed that the Bertillon system was not reputable, that it should not be used anymore. So up until this point, they came up with the new way of classifying people based on the fingerprints, but it wasn't really used yet until this case happened, and they realized that, hey, we need to move away from this Bertillon system immediately so that we can properly identify people and tell one person for the next person. So that was in 1903. By 1924, the FBI started their database. The U.S. now has the largest database in the world because it started such a long time ago. So here we have Will and William West. Okay, they actually were two individuals that they claimed to be unrelated. They ended up in the same prison, and it was almost impossible to tell them apart because using the Bertillon system, when we looked at their body measurements and we looked at their a written description of them, and we looked at pictures of them, full length pictures of them, profile pictures of them, everything match was exactly the same. So there was no real way to tell the difference between Will West and William West. So this was an excellent example. I think nowadays they've actually gone back and they figured out that they were some kind of family member, long lost brothers or something. But they until the day they died, they claimed that they never knew each other and they weren't related. So you know as far as anybody knew, they were not twins or they were not brothers, but they were these two gentlemen that ended up in the same prison, and they looked very, very similar, almost identical, and they had the same measurements and they had the same description in the Bertillon system. So, U.S. versus Byron Mitchell was a case that challenged the uniqueness of fingerprints. All right, so this is a landmark case. But what came out of it was that scientists were able to agree, and the courts were able to agree that they are unique enough and are still admissible in court. So while this U.S. versus Mitchell was trying to challenge that, what we got out of it was that, hey, fingerprints can be used and they are unique enough, they are individualized enough to be used in court. So some principles of fingerprinting. One, no two fingerprints have been found to have identical ridge characteristics. An average of 150 ridge characteristics are on any one fingerprint. So if we look at a single fingerprint, we see that there are 150 different minutia or ridge characteristics. And it really only takes about 8 to 16, some say 10 to 16 matches to consider it significant enough to compare one print to the next print. So if you have that many matches, you can really tell. So you only really need a partial print in order to identify that this print belongs to someone else. It's not like you need a perfect print at the scene and a perfect print from the person in order to compare the two. If you have partial prints, you're still able to make enough matches to say that, yes, this is the same exact print that we found at the scene. So another principle is that fingerprints remain unchanged throughout an individual's life. They're less prominent as we get older. We see that people that work with their hands, masons, bricklayers, they tend to wear away at their fingerprints, but the fingerprints don't change per se. The patterns of them are not going to change. You're not going to have a loop on one finger and then years later that same finger is suddenly going to be a whorl. They do not change when we talk about them in that aspect. But because of this, we can look at fingerprints years, decades later, and still identify where they came from. Dermal papillae, they are the bumps under your epidermis. Okay, they are kind of like the Velcro that connects that epidermis to the dermis. They form these bumps or these fingerprints on the fingertips between the 10th and 16th week of pregnancy. So when you are a fetus, very little in your mother's womb, they're already starting to form. Volar pads. So before we have fingerprints on our fingertips, we actually have these volar pads in the womb, and it's like a little outpouching or pouch-like bump that is on your fingertips. And depending on how they are, and this is genetic, but depending on how they are in the womb is going to decide if you end up with whorls, loops, and arches. And if you ever look at any of your fingers, some fingers might be one type of pattern and others might be another one. So it's not like you're going to end up with all whorls or all loops. So it really depends. But this goes back to genetics. Some people might genetically have when they're in the womb, they have high volar pads on these four fingers, and then their thumb has a low volar pad, or some combination of those. But when we see that we have these the different heights of volar pads or these higher or lower pouches, that's what's going to influence if you're going to end up with a whorl, a loop, or an arch. When we have high or protruding volar pads, you're going to end up with whorls. somewhere in the middle is going to be loops, and then if you have very low ones, you're going to end up with arches. This just shows you if you have a high volar pad, you're going to have whorls. Low is going to be arches. And then if you have one that is on the radial side, it's going to end up being an ulnar loop, which we'll talk about later. And then if it ends up being on the ulnar side, you're going to end up with a radial loop. And when we talk about the integumentary system, we talk about the skin. We have our hypodermis below here, and then we have our dermis, which is broken up into our reticular layer and our papillary layer, and then we have this top part, which is our epidermis. And what brings our epidermis and our dermis together are these bumps that are kind of like Velcro, bringing the epidermis and the dermis together, and we call those bumps dermal papillae. All right, dermal bumps. And those dermal bumps are going to influence the epidermis and the bumps in the epidermis, and that's what creates our fingertips. So why don't more criminals remove their fingerprints? People always ask. Well, it's just not possible. You're not going to be able to do it enough so that you have no fingerprints. So practitioners only need a partial print, and it's very hard for you to remove all of your prints from your skin. So you need to go 2 millimeters deep, which when it comes to pain level, that you're going to have an extreme amount of pain if you try to cut off that going that deep into your skin. John Dillinger, who's a famous gangster way back, bank robber, he actually used acid to remove the fingerprints, and he was unsuccessful because he wasn't able to endure the pain of removing all of the skin on the entire fingertips 2 millimeters deep. So some parts did not go 2 millimeters deep, and ultimately he was left with some fingerprints, and in the end, you know, all that pain, and he still had fingerprints. Any fingerprints that had changed, he now had a new set of fingerprints. So he still had fingertips, and he still had left marks when he committed a crime. So all that pain, and he still had something for the authorities to identify him by. Third principle of fingerprinting is that there are general ridge patterns. We talked about loops, 60 to 65% of people have them. Whorls, 30 to 35% of people have them. And then only about 5% of people have arches. So if you see arches, you know that they're much more rare than other fingerprints. And then we break up those into more specific ones. So there are two different types of arches that we talk about. You have a plain arch and you have a tented arch. A plain arch is just kind of like a little bump. Tented arch, it comes up to a point. And then you have different types of loops. You have an ulnar loop and a radial loop, okay, where you see that this is going to go up, and then it's going to come back. Whichever bone it is pointing to, okay, is going to be the name of it. So if it comes up and it points back to the ulna, it's going to be an ulnar loop. If it comes up and points back to the radius, it's going to be a radial loop. So we always look at that. Whorls are going to have this kind of swirled look to it. Now, the way that we break these up is that how many deltas do they have? So we're going to see, I call them like little triangles, but you can think of it like river deltas. So where you have these areas where it kind of splits into two different directions. So if it has no deltas, it is an arch. So here you don't see those triangles. Loop, we have one here, we have one here. All right, loops are going to have one delta. And then in our whorls, we're going to see that they have two deltas. So here we have one, and here we have two. Central pocket loop whorl, okay, we're going to see that there's usually very high, and there's a low one. Okay, and if you can run through and you don't see that they're going to hit the same ridge more than once, then you know it's a central pocket loop whorl. A plain whorl, on the other hand, we're going to hit the same ridge more than once. So if you see this, we hit it here, and then we hit it again here. That means it is a plain whorl. Then you have pocket loop whorl. You have an accidental whorl, which looks like this. Okay, and then here they call this one a twined loop whorl. But these are all whorls: plain whorl, central pocket loop whorl, twined loop whorl, sometimes often called double loop whorl, more often than not, and you have accidental loop whorl or accidental whorl. So the classification system that we talk about when we talk about the Henry classification system, all right, it breaks up these fingerprints into 1024 different groups, and the way that it works is that it creates a fraction based on the three patterns, and everyone is assigned a fraction based on what patterns you have on your fingers. So whorls are assigned a number. If your finger does not have a whorl to it, then that finger gets a 0. First pair are going to be assigned, if you have a whorl on those fingers, it's going to be assigned 16. Second is going to be 8. Third is going to be 4. Fourth is going to be 2. Fifth is going to be 1. So loops and arches get a 0, and 1 is added to both the numerator and the denominator at the end. So you're never going to have a 0 over 0. All right, that's not going to happen. You're at least going to end up with a 1 over 1 if you have no whorls whatsoever on any of your 10 fingers. So this just gives you an idea. You have your right thumb and your right index is going to be worth 16. If they have a whorl, then you're going to have your middle finger, index finger on your right. They're going to be 8s, and then your right pinky and your left thumb have a value of 4, and your left index and left middle are going to be 2s, and then your left ring and your left pinky are assigned a 1. So here we see that it's going to go 16 over 16, 8 over 8, 4 over 4, 2 over 2, 1 over 1, and then you add 1 to both the numerator and the denominator, and you come out with what your classification is. So here we see that an individual on their left thumb has a whorl, so we give them a 4. On their right middle, they have an 8, so we give them an 8 right there. All right, and then none of their other fingers have any whorls, so they all get 0s. Then you add 1 to it, so 4 plus 1 equals 5, 8 plus 1 equals 9, and then their Henry primary classification fraction is 5 over 9. So by being a 5 over 9, that puts you into one of 1024 groups. So since the 1970s, computer technology has made analyzing fingerprints possible, and the technology is continuing to advance. So automated fingerprint identification system, AFIS, okay, our database that we talk about is scanning devices that convert an image of a fingerprint into a digital version or a digital minutia that shows the ridge endings and the bifurcation. So what it's looking at, what this AFIS program is looking at, is the ridge endings and the bifurcations. That's what it's paying attention to. It's not paying attention to the ridge islands. It's not paying attention to the scars. It's looking at the ridge endings and it's looking at the bifurcations. So it uses this algorithm to determine the degree of correlation. Police no longer need a suspect to compare prints to, but they still need to double check the computer's results. So, once the AFIS is going to tell them that they have a suspect or they have a matching print, they still have to check it by eye, but the computers are getting better and better, and as time goes on, it seems like you don't really need to do that anymore. So different companies make the machines, so it's now standardized. Here, this just shows you different examples of minutia where we have a ridge ending right here, and we have a double bifurcation right here, and we see bifurcation right here, and a bridge, and you have a dot, and you have a core, and right here is an island. Some of these are hard to see, but if you look at a better fingerprint, you might be able to see this is a scar. You have a delta that we talked about, where it's kind of like a triangle, and then a spur going on right here. So these are the different minutiae that you and I can look at, really what the AFIS is looking at, the computer program is looking at, are bifurcations and ridge endings. So different types of prints. All of these prints people will refer to as latent prints. But in reality, latent prints are invisible prints. So if you want to get technical, All right, someone that calls these latent prints, they're technically wrong, but you're going to hear people refer to all these different types of prints as latent prints, prints that were left behind. But there are visible prints, okay, in grease, blood, ink, paint, typically liquids. Then you have plastic prints in solids like putty, wax, soap, dust. And then you have invisible prints, which are going to be left from using our body oils or sweat. Not easy to see, but they are there, and we're going to dust for them. But all are often referred to as latent fingerprints, even though the true latent fingerprints are invisible prints. For getting evidence, fingerprint evidence, initially powder or super glue was used to visualize prints on hard, non-porous surfaces, and other chemicals for more porous surfaces. The old standard was using iodine fuming, followed by an anhydrine treatment, and then use of physical developer. Now they use this RUVIS, this reflected UV imaging system, which is much better than going through all these steps. More recently, laser light for fluorescent illumination has been used since the perspiration or the sweat fluoresces, re-emits light in wavelengths longer than the illuminating source. Once visualized, a photograph must be taken to preserve the print. So once we visualize it, whether we use the old way or the new way, you want to make sure that you're preserving that print. You're taking a picture of it so that it'll last longer than if we just leave the chemicals on or try to use the other modes. So once photos are taken, the evidence is wrapped in cellophane and saved, or if it's on something that's too big, the print will be extracted using some adhesive tape. So if it's left on some giant piece of furniture, you're not taking the whole furniture with you, but you're going to use this adhesive tape that we'll use in class, and you're going to lift the print from there. This is an example of a specially made camera for taking pictures of fingerprints. Digital enhancement has helped practitioners in recent times, so now we have these computers that are able to look at partial prints, and they enhance the prints so that they're easier for us to see. And the software can make a print clearer and uses grayscale to add to the image so that we can see it a lot better. There's different types of dusting powders. We have black carbon dust powder for light surfaces, and then more dark surfaces, we're going to use a gray powder, aluminum dust. In any situation where we feel like we might destroy the print, that the print is very fragile, we're going to use this magnetic sensitive powder. And really, you're by using this magnetic sensitive powder, you're not using that brush, that dusting brush that might wipe away anything. You're using this magnetic powder that is going to latch on to the print. You also could have fluorescent powder for dark surfaces, but a UV light is necessary in order to visualize it. Types of chemicals for visualizing prints on porous or soft surfaces. So when we talk about porous, not hard surfaces, you're going to use iodine fuming. Excellent with paper. Reacts with the starch and paper and residual oils to reveal a print. Will fade after time though. That's why you want to take your pictures. And we can also use an anhydrine, which reacts with amino acids or the proteins in sweat and can reveal prints as old as 15 years. So an anhydrine is very important, very helpful to use. There's other types of chemicals. Some of the older ones, they used to use silver nitrate. They still can use it, but an older one, silver nitrate, which is it's gonna be silver nitrate, and the sodium chloride or the salts are going to be converted into silver chloride and sodium nitrate, and that's what's going to help us to visualize those prints. There's also super glue fuming called cyanoacrylic ester. That's the super glue. It's an excellent alternative for plastic bags and bottles. So if we want to get something off a bottle, we can use super glue fuming. And then, of course, we can use that laser light RUVIS, that UV imaging light, in order to look at the prints. So some things to keep in mind. Children's prints, they do not last long because they do not secrete sebum or oils. That's what the oils in the skin yet. And elderly people have less prominent prints because elasticity of the skin decreases with age. The same thing goes for people that work with their hands. They're not going to have as prominent prints